So this order of operations stuff, it's really no different than what we've been doing, except now, like numbers 1 and 2, they give us some fractional parts. So if this is the case, we should simplify those fractions as kind of as part of our first step. We have to simplify them before we work with them, with any of the outside numbers there. So the fraction line represents division, but we have to simplify the numerator and denominators first before we look at dividing anything. So we got this 20 plus the 25, that's 45 right there. So parentheses first, then we got this multiplied by 3, which would give us 135. And then the denominator, 3 plus 2, that'll just be 5. So we got 135 divided by 5. That's something we could punch into a calculator, and we should get 27. Thank you. 27. So this is what we would have done even if there was something in addition to what we have right there. So let's say that it was plus 8. You'd have to get that 27 before you add the 8 there, okay? Now, of course, that's not what it was. It was just an example. So to work like that on this, we just have to remember that no matter what, we have to stay with the order of operations. So let's look at simplifying this fraction first. We got 200 over 25 minus 5 is 20. So this would end up being, those cancel, and we got 20 divided by 2 is 10. Now the rest of it, we didn't touch the rest of it, so it was plus 5 times 30 minus 5, so we can do the parentheses there. 30 minus 5 is 25. And what usually happens is we get to this point right here. And since we're looking from left to right, which is what we're used to doing, we want to do 10 plus 5 first. But by the order of operations, we have to do the multiplication first. So 5 times 25 is 125. And then we'll add this 10. So 10 plus 125, 135. All right. So looking at this, inside those parentheses, I mean, we can't look to simplify any of the fractions if we can. None of these can be. So we got this multiplication, and then we have the division of the 16/21. So by the order of operations, there's nothing to do with the parentheses. There's no exponents. So we can work strictly with multiplication and division here. So multiplying these two, I got 2 times 1, which is 2, and 9 times 3, which is 27. And yes, we had the two negatives, but they should cancel each other out. So I got 2 over 27 divided by 16 over 21. And from here, we'll change the division to multiplication, but we'll reciprocate this fraction to make it 21/16. So I end up with 2 over 27 times 21 over 16. Now it may be a little helpful to simplify this stuff. 2 and 16, that'd be 1/8. And 21 and 27 can be simplified, but let's do that later. 1 times 21 is 21. And 27 times 8, 216. I'm going to check. 27. Thank you. All right. Well, these two look like maybe they wouldn't be able to be simplified, but again, if we add the digits, we see that these two are divisible by 3. So 21 divided by 3 is 7. And 216 divided by 3.
72.
Very good. 72. And I don't see that that can be simplified. So that would be our answer. That should do it. So we got 3 over 32 divided by 9/16. So just focusing on those two, all right? I'm going to completely ignore that negative 1/4. and just work with my division there. So that should give us 3 over 32, but now it's multiplied by 16/9 because I'm reciprocating that fraction. Now I can look at this with the multiplied by -1/4 because this is all multiplication. So, I mean, we could simplify this stuff, right? 3 and 9, that's a 1 and a 3. 32 and 16 is 1 and 2. That turns out pretty nice. I can multiply all of the numerators. 1 times 1 times 1 is 1. Yes, we do have this negative here. And then I've got 2 times 3 times 4, which is 24. Now, we did do the simplifying in the problem there. We did the cross simplification stuff. In fact, I should indicate that this one was simplified with that. But whether you simplify at the end or the beginning or during the problem, doesn't matter. We should get the same answer either way. This one with the order of operations, we got that division. But again, we have to be careful because instinctively we would want to add these two first. But we can't because the order of operations tells us that we got to do the division first. So we got 2 over 15 divided by 2/3. I'm going to change this to multiply by 3/2. And the 2's cancel out, and then the 3 and the 15 simplify to 1/5. So we end up with just a 1/5. And we got -1/8 plus that 1/5. Well, now we're looking at adding fractions, and we need common denominators here. Looks like the denominator we need is 40. So I'll multiply the 8 by 5 and the 1 by 5, giving us -5/40. And the 5 by 8 and the 1 by 8, giving us plus 8/40. So when I combine these, I've got -5 plus 8, which would be 3/40. That's it. So 7 just gives us parentheses here, so we'll have to do those first. Now we got that 1/3 plus the 1/5. Those are not common denominators, so we need to make them common. Looks like 15 will be our lowest common one. So I'll multiply the 1/3 by 5 in the numerator and denominator, and the 1/5 will multiply by 3 in the numerator and denominator, giving us 5/15 plus 3/15. And combining these, we get 8/15. Now these were in parentheses, and it doesn't matter if you use them now, because it's separated by division here. The 4/5 minus 1/3, we need common denominators as well. So we'll use 15 again. And this gives us, in parentheses, 12/15 minus 5/15. So from there, 12 minus 5 is 7, and we have 15ths. So we have 8/15 divided by 7/15. Of course, we don't actually multiply. I'm sorry, we don't divide. We multiply by the reciprocal of the second fraction, the divisor. So that's 15 over 7. So I got 8 over 15 times 15 over 7. Well, the 15 should cancel each other out, and we should be left with 8 and then 7 in the denominator. That can be simplified. 11 here gives us an exponent, so really this is 3/4 times 3/4. So when we do that, we got 3 times 3, which is 9, 4 times 4, which is 16. And this is divided by the other set of parentheses, which we need to do now. I guess we should have done that first. This one's nice because it doesn't matter. So I'm going to use 12 as my common denominator. I'll multiply the 4 and the 3 by 3. So this gives us 9/12. And then this is minus the 1/12. 9/16 divided by 9/12 minus 1/12 would give us 8 of those 12s. And the 8/12 can be simplified. Not sure if it's necessary yet. Yeah. Let's simplify the 8/12. This one, the 8 is divisible by 4, and so is the 12. So I'm going to reduce this to 2/3. That should make this a little bit easier. 9/16 divided by 2/3. So I'll change that to multiplication and reciprocate the divisor. 9/16 times 3/2. Well, 9 times 3, that's 27. And 16 times 2, 32. I don't think this can be simplified. Not divisible by 3. Yeah, so we're good. All right, this one has a lot of different operations in it. We have parentheses, we have exponents, we have multiplication, and then subtraction and addition. So let's just work in the parentheses first. So I got 1/6 minus 1/3. I'm going to get common denominators by multiplying these by 2. So I really have 1/6 minus 2/6, which would end up being a negative 1/6. Now, yes, that is to the power of 3, and we'll add that to this other set of parentheses, which is multiplication, so that's not too bad. 2 times 3 is 6. 5 times 4 is 20. And we can simplify that, so we probably should. 6/20. Both of these are divisible by 2. So that gives us 3/10. Yeah, that seems like it should be a lot easier to deal with. So expanding these exponents, I got negative 1/6 times negative 1/6 times negative 1/6. And negative 1 times negative 1 times negative 1 is negative 1. 6 times 6 times 6. Oh, let's try that on a calculator, actually. 216. And this is still plus. We had that 3/10, but that's to the power of 2. So this one is 3/10 times 3/10. Which 3 times 3 is 9. 10 times 10 is 100. Eesh. Okay. That's not too bad, actually. Here's what I'm going to do. I'm not going to use the least common denominator on this because that may take a while. So what I'm going to do is if I multiply this one by 10 and the 1 by 10, I'll at least have a number that ends with a 0. So it's some kind of multiple of 10, just like 100 is. So that gives me negative 10 over 2160. And we'll add this to, well, maybe I should have multiplied that by, I should have multiplied it by 100, dang it. So that's just going to add a 0 onto both those numbers. See, and what I can do from here is just multiply 100 by 216 and the 9 by 216. Now again, this does not give me least common denominators, but it does give me common denominators, which means I just may have to simplify in the end. 9 times 216 is 1944, and then 100 times 216 is 21,600. See how that gave us common denominators right there? I just multiplied them by the other denominators. Now this is common, it's just probably not the least common denominator, which is okay. So doing the addition here, we still have a denominator of 21,600. And negative 100 plus 1944, that's 1844. And now I'm just looking to simplify. Looks like both these should be divisible by 4. Let's try that. 1844 divided by 4. That's 461. And then 21,600 divided by 4, 5,400. Well, 461 is not divisible by 3. Is it divisible by 6? No. That looks like it's it to me. Double check. What did I do? Blank. So yeah, that's it. All right, this one has a lot of order of operations for each of these. So the first thing we should do is the 9 plus the 7. So I'm not going to touch anything else yet. 9 plus, I'm sorry, that's 9 minus 7. What the heck? That's 2. And then in the denominator, we got 8 times 3 plus 2. So that gets rid of our parentheses. So from here, we're just looking for exponents, which there are none. And from there, we're looking for multiplication or division in either the numerator or denominator first. So we can see that we got this 4 times that 2. So that would be 5 plus 8 now. Over in the denominator, I've got this 8 times 3, which is, 24. There we go. Plus the 2. Well, now this isn't too bad because I got just addition. I got 5 plus 8, which is 13. And then I got 24 plus 2, which is 26. And it looks like this can be simplified by dividing both these by 13, which gives us 1/2. Complex fractions. You guys have seen these before. We just didn't show them as fractions, okay? This is division of fractions. For example, this one, I prefer to emphasize this line that's between the two fractions a little bit more like this, because what it does is it separates the numerator and denominator of the big fraction. So what I end up with is I got 21 over 52, and then the fraction line here, the big one, that represents division, and then I've got 10 over 13. See, that looks a lot better and something that we're probably a lot more used to. So again, we would change this to multiplication, and I would flip the fraction, 13 tenths. So I got 21 over 52 times 13 tenths. Yeah, let's do that. 52 and 13, that should simplify into 4 and the 1 there. Well, that should make it a little bit easier. 21 times 1 is 21. 4 times 10 is 40. There it is. So you see, again, I mean, this is just a different format for dividing fractions. But we will see some where there's a little bit more, maybe a couple more operations in either the numerator or denominator. 4 has this 3 tenths plus the 2, right? So what we need to do, and again, we got this big fraction line. So whatever it is, it'll be ended up being divided by 2/5. Well, we just need to figure out what that numerator is. Now that's 2 over 1, so the common denominator will be 10. So I have to multiply these by 10. So this equals, and we can put that in parentheses if it helps us see that better, 3 tenths plus 20 tenths, which when I add those, I get 23 tenths. And this is divided by 2/5. Once again, change that to multiplication. We'll flip the fraction to 5/2. And we got 23 tenths times 5/2. 5 and the 10 simplify to 1/2. And I got 23 times 1, which is 23, over 2 times 2, which is 4. Let's do 5 here, because this one, again, this is just a matter of rewriting the problem usually for us. So this ends up being -4 divided by this 3/4. So we'll keep the -4, but we'll change the operation of multiplication of the reciprocal of the divisor. So if it helps us, we can see that as -4 over 1. -4 times 4 is -16. 1 times 3 is 3. Bam, there it is. So this one, I mean, it looks different, but hopefully we see that it's not, I don't think it's even as complicated as those first couple. Now this one looks pretty destructive. So let's simplify it so that it looks a lot easier to look at. In fact, I'm just going to rewrite it like this. So I got 1/3 minus 5/6, and we'll divide that by, because that's the big division sign right there, 3/4 plus 1/2. Now, if this still isn't easier to look at, you could have worked with the original complex fraction. By the way, a complex fraction, I apologize. A complex fraction is just where we have a fraction inside of another fraction. And this one has a lot of fractions inside the fraction. So, we need common denominators. I'm going to use 6, so I'll multiply these by 2. So now I have 2/6 minus 5/6. And then over here, we'll multiply this by 2 and the 1 by 2. So I got 3/4 plus 2/4. And this is divide. Simplifying these, I get negative 3/6. And then in the red, I got 5/4. Again, we got divide. And the 3/6, we can simplify this by dividing both these by 3. So now I got a negative 1/2 divided by 5/4. Yeah, I got the parentheses there, and if you don't have them, that's okay. So we'll change this to multiplication. I'll flip this fraction to 4/5, and I got negative 1/2. Oh, that didn't come out right at all. 5ths. And the 4 and the 2 can simplify. So we got negative 1 times 2, which is negative 2, over 1 times 5, which is 5. Negative 2/5.